Hello, everybody. My name is Ilya Gavrilik, and I'm a Vice President of Real-Time Computing Lab. And today, in my presentation, I'll be talking about history of innovation, experimentation, creativity. But before I start, I would like to say really thank you for the opportunity to present to you. And it's a privilege, and it's an honor, and it's a pleasure. And I really would like to make sure that we all appreciate it. So the topic of my conversation today would be innovation, creativity, experimentation in the context of real-time computing lab, and specifically CryptoCortex. So, as I said, I'm Ilya, I'm Vice President of Real-Time Computing Lab, and in my presentation I will talk about results of innovation. We'll talk about specifically 3D immersive reality technology, which we're experimenting recently in order to sort of change the way people communicate. And we'll talk about real-time computing lab products, specifically BioAggregate, Analyze Act platform, and CryptoCortex, our recent entry in the cryptocurrency trading space. And with that, here's what I'm going to be doing in the next 30 minutes. We'll start from description of 3D immersive reality. What exactly we did, why we did it, what happened. And then we'll talk about real-time computing lab overview. At this point, I will join you in my virtual exhibition. And everything we do today would be not a hard-coded sort of PowerPoint presentation. It will be pretty risky. It will be real software with real bugs, with real sort of, live effect. And so we'll talk about real-time computing lab overview. I'll walk you through museum. We'll talk about our core products. We'll talk about solutions, technology. And then we'll dive into time-based CryptoCortex. And finally, if time allows, we'll do question and answers. So with that, without spending too much time, I'm closing my PowerPoint and we'll go to this homepage. So the homepage of EPAM Virtual Experience Exhibition contains of 3 different pavilions: EPAM History Museum, EPAM Made Real Lab, and EPAM Real-Time Computing Lab. And I definitely advise you to hope that you will be joining the History Museum and the Real-Time Lab, Made Real Lab separately. But right now we'll jump into my place. This is it. Here we are. We're inside the pavilion, which is EPAM Real-Time Computing Lab. Let's talk a little bit about what is the motivation behind all this technology. So what was the motivation behind decisions to try new user interfaces, new experiments with communication between people? I mean, we obviously live in this COVID world where things get virtual, things get isolated, social distancing, and the feeling of being contained in the same environment is definitely not a pleasant one. So in the last many years, I've been personally working with different technology providers. Not every innovation real-time computing lab was done by us ourselves using our own proprietary technology. A lot of times we would partner with companies. In this particular case, we partnered with a company called Roomful, and with them we prototyped the environment where we can feel more in tune with each other. So as you can see, there are people walking in our room, and we'll definitely approach them at some point. They've got EPAM logos on their backs. So if I jump into this booth, you can see right now the people watching, for example, QuantHub technology. So let's go and start this exhibition from looking at a real-time lab directory. So we have 6 products, which we're going to talk today about, some of them, and we'll start from real-time computing lab. We're joining the booth and we're seeing the pavilion. So let's jump inside the booth and start the journey. So real-time computing lab, which is kind of tagline, is event processing at scale, was founded by us, me and a few of my partners in 2005 as a company called Delphix. And the goal was to sort of explore innovative methods of working with quantitative methods of working with event processing. And specifically, we work on application for quantitative trading. So we put a platform for systematic trading, robot trading, which we can see some piece of it today. And this platform evolved the message evolved as well, and today we have aggregate, analyze, act methodology. That's very important. So we have three main pieces: aggregation, analysis, and acting upon these pieces as a part of our domain expertise and a part of our IP. So key facts about our lab: we have 225 clients, we have 15 years in operation, we've got more than 90 engineers, we spent more than 800 million years working in this technology, and now it's a part of EPAM. We've been acquired in February, and we're very happy to be inside the community. This is us, this is our leadership team. As you can see, everything here is dynamic. It's not it's a poster inside virtual exhibition. This is our skills. We work on financial services, we work on Internet of Things application, prototyping visualizations, and specifically within financial services, we work with the cryptocurrency trading. Finally, a little more color about aggregate, analyze, act platform. So three core technologies: Timebase, which we're going to spend a few minutes; Front Office, which is our analytical studio and execution server; Act as the techniques for collect information, process it, and execute. So that's a brief overview about Real-Time Computing Lab. I'll just go back. I'll show you a couple of examples of our work as well. We have, for example, some screenshots in this environment where we can look at specific visualizations. And one of our products is real-time math library. Let's start from here. Let me just show how the whole this thing works together. With one mouse click, I'm jumping to a website of real-time math, and this is the testimony of our capabilities within the EPAM to work with quite advanced mathematical areas. So we understand pretty much. We wrote this product, and the motivation behind this product was very simple. We spend a lot of energy and a lot of time working with ultra-low latency trading. We're microsecond meta, and when you talk about microseconds, every calculation has to be done at the highest possible speed. And that's why we wrote special libraries, and we sold them as a special IP, and now it's a part of EPAM skills and infrastructure. Well, as you can see, I go around the room by jumping back and forth. For example, every time I click on a home button, I go and I just go to my directory. But if I want to just walk in the free form, I just click on look around, and I can just walk by basically clicking on move forward command. I can turn left, turn right, go up, go down, and so on and so forth. And the reason why I think this is also a very interesting way to engage with people, that it allows us to engage in our three-dimensional kind of animals. We all receive three-dimensional information much more efficiently. We're wired with what's called memory palaces, and I would like to sort of explore how it all works. So now let's go back to the table of content and jump into Timebase. Next stop on my journey would be Timebase. So, Timebase is a high-performance streaming time series database and also messaging middleware. And if we jump into the booth of Timebase, we'll get a little quick introduction about what it's all about, and we'll see the presentation recorded by one of our engineers. And this is, again, management team. Everything we do, we have people who innovate, who decide what to do, how to work, this Timebase architecture. And at this point, I'd like to jump and show you live demo of Timebase. Let's do that. Let me, first of all, stop my screen sharing. I will remove myself because now I would like to jump into the room. So for that, I'll go to what's called presentation board, and I'll start, I'll start the video conference. So we can now all join each other inside this environment. And I will be projecting my face, and here I am, right inside this room. I'm inside Pavilion. I will be saying hello to you guys, wave my hand right inside this room, which I think is pretty cool. And I put multiple screens which illustrate that multiple speakers can join each other and present actually different pieces. And in fact, I'm going to connect right now to my different computer and show you the demo of Timebase right inside this environment. So here we are. Let me actually pause my visualization, bring the screen to the full, enlarge it, and let's come to this place. First of all, let's go to timebase.info website. This is, as I said, high-performance time series database and messaging middleware. And when we visit this website, you can study why Timebase, what exactly we did, and use cases, like I said, financial markets and for Internet of Things. This is all cool stuff. And there's documentation and so on and so forth. But now let's go look at the live demo of some of our technology. We'll come back later to CryptoCortex. We'll be there in a few minutes. But first step in CryptoCortex is analysis of real-time market data. And so in this example, I'd like to share with you how this information would be accessible for real. So each of these nodes represent a source of data. For example, this is data from Bitstamp, or this data comes from Bitfinex. It's a different source of data. And if I tell on command inspector, then we will see as it happens, real-time streaming of data with actually millisecond timestamp. This is all the data points. At the top, we see the latest information about each particular instrument at a particular point in time, and at the bottom, we see history of all these messages. So anytime I click on the row, we will see the JSON APIs representing the type of messages which are currently streaming. This is the prices for cryptocurrencies, but any time series data could be immediately visualized. Now if we go to look at charts, that'll be pretty cool. Like I click on command chart, and we'll stream live from our servers information about market as it happens right now. So at this point, it's market data streamed with 10 levels deep. Like if I wanted to, for example, zoom deeper and look at, say, 50 levels, this information represents the asks and bids which are currently placed on exchanges. In this particular case, it's the Bitfinex exchange, and this is the data. This is it. I can zoom in and I look at it right from like at my fingertips, all this information, and we can see spreads, we can see latest actions, and the most cool part, at least for me, that we are right now in this room. So if I just change my focus, go back to my room, and I move around, I can zoom, or I can go back and look at the pavilion, how it looks. So let me go back to my home and talk about next stop in our journey. Let's go to CryptoCortex. So same idea, we get into Pavilion, we're looking at materials of CryptoCortex. This is recording of the presentation and describes the management team, leadership team, and again, examples of front-end user interfaces and all the materials which are relevant would be possible to discuss right in front of us. So let's talk about this particular slide. So, which represents the architecture of CryptoCortex for secondary markets. On the right side, we connected to multiple exchanges, and then we aggregate data inside Timebase, and we stream this data to pricing engine, which would allow people to, let's say you're a broker and you want to stream your prices to your users, then the pricing engine will be applying your custom algorithms, and data will be distributed through FixHub and streamed to different types of clients. And then one of clients could be market maker, which we're going to talk later about. Other clients could be the systematic traders or discretion traders. Order flow later represented in the brown color and goes back to matching engine and streams to execution management server and back to exchanges. All this can be also represented, visualized on a bigger screen. So if I go right now to this diagram, we'll go to website. We're going to this website, or as you saw it before, it's more natural for me to go to my presentation panel and talk about CryptoQuartz here. So let's just go here. Okay, so let me blank Timebase and start from CryptoQuartz in this context. Make my screen a little bigger. I'll make it a little more easy to read. And we'll stay here for the next 10 minutes because I'm going to show you a lot of cool demos of this technology. So let's go back to architecture. So this is where we talk about aggregate, analyze, act story pretty explicitly. As we've been here before, Web Administrator aggregates data from multiple data sources. And by the way, on this website, everything is actionable. So if I click on I, we'll go to full-blown documentation. So everything is at our fingertips. All documentation is right here. Market data connected to aggregator goes to trading server, which makes decisions about how to trade or what to trade. There's multiple use cases. We've got two different front ends. Then system goes to execution server and to fixed gateway. Let's visit trading UI. Now let's have fun. In this UI, we will be watching another kind of innovation where we connected to 50 crypto exchanges where data is aggregated from different sources and represents right now the actionable prices as they are on the market. So as you can see, market is actually volatile, and right now Bitcoin is going back to 60,000 from 20,000, 19 few days ago. And this, what we see here, is live data. But look at this, right? We're inside the virtual exhibition. We're inside our virtual room, yet we see the actual software running on one of our servers represented in one of our environments. And here we can all share all this information on tape and make a lot of cool things together. So I myself very excited about this because I can promise to you it's probably one of the, maybe the first, maybe the only one, presentation of cryptocurrency trading technology inside virtual three-dimensional room. Cool. So let's do a couple of interesting things and study how CryptoQuartz works. Let me hide this panel. Okay. Step one, just this exchange. So in exchange, any user can place limit orders. So let's go right now to this environment. I'll place limit order, and I'll show you how this order would be executed, or at least placed. Let's say we're going to buy 2.5 Bitcoins, and we're going to place limit order, place it at exchange called, say, for example, Quartz Exchange, which is one of our own exchanges. And I'll pick a price, I'll click on the chart, I'm going to sell it at a high price. So we book the price, and we tell system that we would like to, at this price, place at the Quartz order, and we're going to make time in force, not good until the end of the day, but good till cancel. So as I place this order to sell, and I confirm it, the order gets placed. You can see this event, and we can see in our order gateway, if I just click on orders, we've got limit order, the price at this particular cost. Now, let's go to another component of CryptoQuartz. Let's go to management panel, and we'll go to architecture, and we'll visit the configurator, which is responsible for end user management. And so, again, we're inside this room, we're streaming all this data, this is all actionable prices. I'm going to user dashboard, which I currently represent, which is tester 1 at demo.com, and under trading, we will see that we did place indeed limit order. You can see it right now, the order ID and this limit order to sell at 2.5 Bitcoins at limit price like this, an exchange called Quartz. This is all definitely actionable software. So now I'm as administrator of Exchange, I can actually even cancel this order on behalf of a user, or despite the user desire. I can click on command cancel, define the reason to cancel. For example, no rights trade. And when I send it, order will be canceled. We'll go back to our trading front end. We'll see that order is now basically was disappearing in order to be canceled. And with that, we're seeing that there's no more active orders for this particular user. And the record of this transaction will be in database. Now let's have more interesting stuff. Let's buy and sell cryptocurrencies. Let's use something called smart order routing. Smart order routing is a technique which allows us to route execution of order on multiple venues and execute them at best possible price. So let's say I want to place a large order to buy 50 Bitcoins and define the 50 quantity, and I tell system that instead of sending order only to CryptoCortex, I'm going to send it to venues within smart order routing environment. And let's say you can see right now that this system immediately shows us how this order would be executed. It will be broken into pieces and executed in different venues. So in this case, if I want to buy, let's just go say we want to buy this order, and we're going to tell that we're going to buy market order. I click on command confirm, and bingo, order is immediately executed. I mean, obviously we work in a simulated environment, and this on the right at the bottom, we see the different events. So if I scroll, there will be the different events associated with this. But obviously we don't want to look at this such a small window. I'll copy paste this order, and I'll go to one more element of our ecosystem. I'll go to what we call monitoring infrastructure. So I'll type here monitor, and this will give us another very important view of everything which happens inside our servers. So as you see right now, we process today 30 million orders, and one of these 30 million will be found by us right now. I click on command order. As you remember, I copy pasted it. I click on command paste. This is our order. I'll find it. Bingo. Order found. We see that it's been filled completely on Exchange on the destination called Smart Order Router. Double click on this. We see we got 100. It's kind of a funny number. Exactly 100 child orders, 100 minimal executions. And there's a tool called Alga Order Inspector, which shows us that this particular order, oh, that's so cool, is broken to 6 venues. So we run it, and as you can see, market is volatile. 19 Bitcoins were purchased on Kraken, 7 on Bittrex, 6 on Gemini, 9 on Bitfinex, and you can see right now only a small portion on Coinbase and Bitstamp. Why? Why did we do it? Because as you can see, the prices on all these exchanges at any point in time are slightly different. And this represents the arbitrage even. We have constantly moving targets between different venues. We can buy on Gemini and sell on Coinbase. We'll have arbitrage of $2. Coming back to this future monitor, we see that all these transactions also represented, like on Kraken we did 24 transactions, and on Bitfinex we did 39. Each of them is represented here. This technology, for Aggregate Analyze Act, has a multiple different visualizations, different use cases. What we did a second ago, we looked at CryptoCortex. But if I want to look at additional use cases, let's say I would like to go and examine instant payment framework, which is developed using the same technology. I'll go to EPAM, come to Real-Time Computing Lab, Payments, and I'll go to Instant Payment Network. Here we are. This is our instant payment dashboard, which shows us what happened with the last minute, and each payment represented again in a similar way, a similar object. In this particular case, instead of talking about cryptocurrencies and capturing the messages, events in the form of cryptocurrencies, now we're talking about events in the form of instant payment messages. Each message here represents, it's obviously a simulated environment, but it's a very cool simulated environment which displays the ability to act and process transactions between different counterparties. So this is telemetric component which we designed using our proprietary APIs, and just for fun, we also could show you how we go and engage in Grafana frontend. So similar technology, going to Baymans, I'm going to Grafana, and this exactly same dashboard shows us the exactly the same information, except here I'm saying what's going to happen not in the last 6 hours, but let's say in the last 5 minutes. And let me switch the focus. Last 5 minutes. Here we are. This is it. We're looking at transactions. We look at monitors. It's all live. It's all real. If I look at transaction rate by state, here we are. This just simulates the different components. And coming back to museum, we are back to our conversation. So other products of Real-Time Computing Lab are all represented here in the form of directory, and we even exploring and innovating with different promotional sort of elements where you can have this type of dynamic cubes. You can see score points at the top of my screen, which explain like if I want to engage with some people for gaming, we can attach certain points with certain information, quizzes, answers, questions. It's all here. Two more things. As you can see, these avatars are moving around. They are all having EPAM logos. They're kind of funny. I mean, they obviously we can enhance the way they move, but you know, this is still a work in progress. What I'd like to show you, one also interesting element. This is here. As you can see, my demo with instant payments in the background, and as I go here, I can definitely change it. But I'd like to show you this piece. This is another sort of element of innovation. Whereas you remember, CryptoCortex architectural diagram was represented in the form of sort of 3D picture. Now we decided to animate it and see what happens. I don't know how this experiment would be, whether it's going to be useful or not, but you never know, right? In many cases, you do innovation, you try certain things, and we made so many errors, so many mistakes, only to learn what the right thing to do. So we just created exactly the same replica, assuming that in every box and every visual object we can definitely store a lot of additional information. So, as you saw today, we're jumping from point to point, but we are in this live environment. Everything here is live, everything here is actionable, and I'd like to finish with coming back to Real-Time Computing Lab and saying the following. Let me go back home. Let's go back to Real-Time Computing Lab and talk about the following. So we are constantly looking for talent, right? And at any point in time, yeah, by the way, I forgot to show you some very cool feature, very useful feature. Let's say you wanted to talk to any representative, any booth. Let's say you're inside Timebase and you want to tell, hey, you know what? I'd like to learn more about this particular information. So I can immediately send a mail. I mean, it just happened to be that I am right now talking to a Timebase representative, and the mail would be sent, and the representative will be in touch with you. So we definitely have ways to engage with people and talk to them. And let me just resume my video. So what I'd like to say at the end of my presentation, that we're hiring, right? We're constantly in search for talent. And this where, again, we can come here, we can basically make a pledge, and finally, we're going to be coming to EPAM recruitment site, where we're talking about careers at EPAM and link your virtual experience with actually engagement with EPAM. With that, I'd like to thank you for a fantastic opportunity to present, and any questions, please, you know how to ask, and also you know where to find me. As I showed you a second ago, I am Ilya Gorlik at epam.com. Thank you very much.